So here in Tinkercad, basically we will just go with the basic design of a circuit, and we will just introducing the basics about Tinkercad, like how we can use the Tinkercad for basically creating our project or basically the lab related activities. So we will have just a practice here in the Tinkercad, and then we will be once we will be going through the basics of the Tinkercad and all the circuit arrangements, like how the circuit connection should be there. And once we will be completing here, then we will be having some like work related to like some assignments to work based on the Tinkercad, and then finally we will be using the practical components in the lab while the lab classes will be going on. So here, with the help of Tinkercad, we can design different 3D designs. We can have a 3D designing type of component. We have circuit design, and here some code blocks are there. We can design the code blocks also. So basically, we will be focusing on like the circuit designing part, like how we should be connecting different components to create a basic circuit. So we'll just start with the basic one. So we'll start with the first, like to create. So we will be creating what we need to create the circuit. So we should be creating a circuit first. So we will be clicking on that. You need to create an account on this Tinkercad by the college email. You can have any email ID. You can create the account by using any of the email ID. Okay. Okay. So this is the basic window that will be basically created once we will be logging in and going to create a circuit. So on that, this is the file name that will be created. So you can change the name by double clicking. Okay. You can have any names. So suppose we have changed it to demo. So it will be changed to demo now. So now basically here code block is there. That means we can provide the code also. So if we are using Arduino kits, once we will be providing an Arduino using an Arduino kit, then for that Arduino we will be able to write the programs. So in the code section we will be able to write the codes. Okay. Once we have done all the connections, we will be clicking on here start simulation, and once it will be starting, so once it will be starting mean whatever circuit we have connected, it will start running or it will start executing the program that we have written into the code section, or whatever circuit we have drawn here, it will be start working basically. If we want to stop it, we need to again click here. So once we will be starting it, it will be coming now. The next is stop. Okay, we can send the design that we have created to different locations. So auto disk, some dot files we can import. We can share with some email. We can take download the pictures and the diagrams also from here. And here are like we can put some nodes into the circuit. If you want, we can put some nodes. And here is the color. Okay, so whatever the wires are there, we can change the color of the wire. This is the different types of wires. Okay, so first of all we will be going with the basics of the circuit, like how a circuit look like, how we can draw a circuit, what different components will be there. So basically we'll be using battery basically here. So we will be starting with the battery, and with an LED, how a battery and LED will be connected, we will be connecting with that. Okay. Also here components, once you click here, different components that are available are categorized into different sections basically. So basic components that will be most frequently used. So comes across the basic components. Another one is all components, means all the components will be coming out. So whatever components we are selecting, that will be coming. If we select all the components will be here into the drop down. Okay. If we click on the basics one, only the basics one will be looking. Which one? You can search any of the component by typing the name. Like suppose we want to search for an battery. So we will be writing battery. So there will be whatever different options are there for battery that will be coming out here. So we can have 15-volt battery, 9-volt battery, a simple battery, okay, a fine cell 3-volt battery. So different type of batteries are there. If you want to search for a capacitor, you can type here and it is coming out here capacitors. First we will be using the resistors. So here registers are there. We can use the registers. Okay. Some sensors are also there. So we'll see one by one. Okay. So we'll be just starting with the basics part. So how a basic circuit look like? We will just draw a basic circuit. So for drawing a basic circuit, we need a power source. That power source will be a battery. So we will be taking a 9-volt battery. So we can take it. Once we click it and put it here, it will be dragged out into the circuit block, circuit window basically. Once we click here, we can name this component. We can name it here. Okay, whatever name you want, you can name it. If you want to rotate it, you can rotate it here. So if we mirror it, you can just see here plus is there. So two terminals are there, plus and minus terminal. If you rotate it, you can just see plus goes up and minus goes down. So you can mirror it here. Okay. If you want to rotate it, this is the rotate. So for rotating, there is a shortcut also showing R is there. So either we can click here, we can rotate it, keep on clicking and it will be rotating. Okay. Or we can use the shortcut R. If we type R, click R, it will be rotated. Okay. So we're placing it here. And once the battery is there, we need to now have an LED. So we'll be connecting an battery with an LED. So there are different types of LED. RGB, there will be 3 different types of colors are there. It will be glowing in 3 different colors. One is simple LED. So we will be clicking not clicking for that and it will be placed here. Now in the LED, we can change the color also. Okay. Which color it should be, whatever the color we want it to be, we can change it here. Okay. We can change the name also. Also, once we go to the pins, LED will be having 2 different pins. One is cathode, another one is anode. So cathode and anode is basically going to indicate like if an anode is there, that means we need to connect the positive terminal of the battery with the anode so that the LED should be glowing. Similarly, the cathode should be connected with the negative terminal. So for connecting, we need to have a wire. So once we click here, it gives like negative. This is positive. So positive is given by the red color and the negative is given by the black color. And here cathode is the negative, anode is the positive. So we will be connecting it here. Once we go here at this pin, it will be highlighted and then we will be clicking and then move. Click and move. Okay. Once you have clicked it, if you want to reshape, we can reshape it. Next one is the positive one. Again, the positive one, we will be connecting it here. So this is like this. Okay. So this is how the connection we can make. So once we have made the connection, for better understanding, what we can do is we can change the color of the wires basically. So this is negative and it should be black color. So we'll be changing the color. Just click on the wire and change the color. It will become black. Similarly, this one should be like it is positive terminal connected with the positive terminal. We should be making it to a red color. We can make it red. Also, whatever the colors are there, this is the first color. So 0, 1, 2, 3, 4, likewise the numbering is done. If you want to make it like black color, just highlight it and press 0. It will become the color. It will basically change the brown color. Okay. Similarly, if you place 1, it will change in the color black. Similarly, if you change the by 3, it will change it. So each color is being coded. Okay, accordingly we can use the numbers also to change the color. So once it is a complete circuit is there, if this is the LED that need to be providing the output, and this is the energy source that is connected. So it will be once we start running or start simulation, it will be working. It should be glowing. So once we start, it is glowing. But it is once we go to close to here, you can just see like the current through the LED is 915 milliampere, while absolute maximum is 20 milliampere. That is saying like there is lots of current going through this LED. Only 20 milliampere should be flowing through this LED, but it is 915 milliampere flowing. That means large current is going through this LED. So to stop the large current going through here, we need to use. So first of all, this is showing some error or some warnings are showing. So we should be stopping it first because it should be having like only 20 milliampere of current should be flowing through it this LED, but we are making it flow to like 915 milliampere. So we should be using some resistors to connect this LED so that we can resist the current flowing through this circuit. So now we will be using some resistors. So these are the resistors. Once we click it and come here, and then we can rotate it by pressing R. Delete it and then place it here. Now basically we will be connecting it with the wire. First we with light color. We can change it direction. Okay. So now that is that. Once we click on the resistance, we can just see there are different resistors available and different resistance values we can put. So here 1 kilo ohm is there. We can have different in ohms also. We can have the values into kilo ohms. Okay, so we'll just starting with 1 ohm. Suppose we have placed 1 ohm. Okay, and if we run it, then again we go here. Again it is showing like the resistance we have placed with respect to that the current is 808 milliampere. Previously it was 915 milliampere. The current have reduced, but not reduced to that much level because maximum current that should be there is 20 milliampere through an LED. So we need to further increase the resistance value. So we'll stop it and we'll go to here and change the value. Suppose it is 100 ohms. Initially it was 1 ohm. Now we want to change it. Now it is of 100 ohm. If we start simulating again, just it is not showing that warning, but again you can just see there is a symbol here. Just if we click here, it is like current through the LED is 65 milliampere, while recommended maximum is 20 milliampere. The usable lifetime of LED may be reduced. So that's the thing is, if we are using an LED with that much of current, then its lifetime period or the time period for which the LED can be used will be reduced if we are keep on using this LED for 65 milliampere. So we need to further reduce the current flowing through this LED. So we'll be increasing the resistance value again. We stop it, changes to like 200 ohms, and then again we will start the simulation. Now if we go there, it is again 33.8 milliampere. So again we need to change the value to we want to make it to 500 ohms, and then we will be starting. So once we started, there is no warning is showing. That means it is into the permissible limit of 20 milliampere. That means the current flowing through this LED is less than 20 milliampere. That's why it is not showing any warning. So whenever we will be connecting a load like a LED bulb is there, we are connecting. So whatever the current that it is possibly passing through this LED should be into the upper limit. Okay. So its maximum limit is 20 milliampere, so this to be less than 20 milliampere so that its lifetime is improved. So we should be basically focusing on, like, if we are using LED, we should be connecting a resistance. So in case of lab session, once we will be using the practical components into the labs, at that time, whenever you are going to connect an LED, make sure you are using a resistance, and resistance should be minimum of like 500 ohms. It should be 500 ohms so that the current reaching to the LED should be into the permissible limit. Okay. So this is the basic circuit. Now we will be using a switch also. So this is the resistance we have put. We want to place a switch. So we will be disconnecting it and we will be using a switch. This is one of the switch type. Okay. So we will just rotate it and come here. So this is a 3-pin switch. So switch is like, if you place it here, so if we turn it on and off, so this is the common one. This is the terminal 1 and this is the terminal 2. That means if we further rotate, so if we rotate it further, it is like 1. So we will be disconnecting from here because this is the common one. Because this is the common port, so we will be connecting the battery positive terminal with the common one. Okay. Now, if we place this switch button up, this up terminal 1 will be activated and we should be connecting here. If we are connecting the terminal 2 with the LED, if we place this switch button to this side, this will be on. Terminal 2 will be on. Okay, this was the common one. So common will be connecting with the battery and output we can take from any of the terminal. So it is like a switch that is working for two terminals basically. So either it can be activated on this terminal or activated on this terminal. So we'll be using the terminal 1 only. So if we use it, terminal 1, okay. Now we have connected. If we start simulating, once we start the simulation, you can just see the LED is glowing. That means the circuit is connected. If we change the switch value, this is off. This is off now. Once we change the switch, it is on. So with the help of switch, we can control the on and off. So instead of this, you can just think of like the microcontrollers that we basically uses is like behaving like a switch itself. If you are providing a sensor data to the microcontroller, once the sensor receives the data from the microcontroller, it will be activating particular terminal of the output pin. So once it is activated means it is behaving like a switch only. So with the getting some input from a sensor, it will be activating another pin, either low or zero. So once it is going to make it low or zero, accordingly the LED bulb, or there can be like a fan. The fan can be, or a motor can be rotated. Similarly, if we are having a switch, based on that, either we can rotate the motor or we can turn on and off the LEDs also. So this is like an output device, or we can call it like this is an load basically. Output device here. This is a switch and this is the resistance. So this is the power source, that is a battery. Okay. So this is the basic of circuit that can be here. Okay. So next, batteries can be of different types. So either we can use this battery or this one or any of it. So once we will be preparing the circuits in the lab part, we will be providing you with the breadboard. Okay, so we will just save this demo. Okay, we will take like another basic component. So we will start with the next one. Next circuit we will see. We'll take the next circuit with the help of breadboard. So what is breadboard? We will see. So here renaming it breadboard breadboard circuit. Okay. So we'll just introduce like what is breadboard is there. So breadboard, we will be searching it here. Okay. So there are different types of breadboard. So we will see this the small one. What is small breadboard is there. So in the lab part also we will be having the breadboard. So all the connections. So in the previous circuit, we have made the connection without a breadboard. But now when two wires need to be connected, so breadboard is basically easy to provide the connections. So if we are having two wires to connect in the Tinkercad, we can easily connect with the wire. But in practicality, we should be connecting two wires with uh, terminals each other connected each other, connecting each other. But to provide a proper connection, we generally use the breadboard. So in this breadboard, you can just see like if we are there are different holes. Okay, so you can just see if we click on this hole, all the holes are highlighted. That means if we are providing any value voltage to this terminal, all the holes that are highlighted will be having the same values. That means the F, G, H, I, J, these are the holes that are having the same potential. So if we connect any value, any voltage to any of the holes, it will be having the same potential. Similarly, in the second column is 2. So second column, all are highlighted. That means in the second column also, any of the terminal we will be connecting any voltage value, it will be the same voltage value can be coming across all the terminal holes basically. Similarly, likewise, for all the vertical holes, it is having same value. That means these are sorted together. Sorted means these holes are connected to each other. Okay. Similarly, in the downside also, so A, B, C, D, E. So column number 30 with A, B, C, D, E rows. These are having the sorted values, sorted holes basically. So that means these are called vertically sort. So these are vertically sort. So this A, B, C, D, E is not sorted with F, G, H, I, J, but individually F, G, H, I, J for column 30 are sorted. Similarly, the A, B, C, D, E holes for column 30 are sorted separately. Okay, so you can just see the highlights. So if we click on any hole, whatever the holes are sorted, it will be highlighting it. So these are called vertically sort holes or pins basically. Okay, next we will see here on the downside, two horizontal rows are given. So once we highlight it, all the rows are highlighted. That means these holes are sorted to each other into the uh, breadboard. Similarly, the second one is also like all the highlighted holes are there. They are sorted to each other. If we connect any terminal, any voltage, suppose here we connect to ground, all these holes will be showing the ground terminal only. So that's why it is given plus and minus. So once we have to use plus and minus like VCC, the ground, again and again, we will be making these two lines as VDD and ground. Okay, or the high voltage and the low voltage. Similarly, on the top also, we'll be having two horizontally sorted holes basically. So these are sorted lines. So these are sorted lines. We can use any one of these for positive and negative voltage creation. So this is the basics of breadboard. Here, some vertically short lines are there, and some horizontally short lines are there. So how we should be connecting with the components? We'll see that. So we'll be again connecting with battery. We are having a battery. We will be rotating it. So this is the battery. Now in the battery, all the terminals, all the pins that all the components that we will be connecting will be basically connected to either positive or negative. So if it is negative, so we'll be just rotating it So you can just see this is the positive. So this is the positive. We will be connecting it. Okay. So if we connect it likewise, if it is positive, we should be making it a red color. Okay. Similarly, we will be connecting another. Okay. And this is negative, so we will be making it a black color. So now the battery, positive and negative are here and here. Negative this one, positive this one. So whenever we need to connect an LED, so we'll be taking the LED. So in the LED, we'll be connecting the LEDs because let's see, because these are the vertically short. This is vertically short, means these two lines, lines 121 and 22, are not sorted. So, but once we place an LED, we can't place the LED likewise. We can't place the LEDs likewise because these pins of this vertical line are having the same voltage. If we connect this LED likewise, both the LED terminals are connected with the same voltage. So there will be incorrect connection. So we should be rotating it further. We should be connecting such that each terminal should be connected with two vertical lines. So this will be the vertical line for anode, and this will be the for cathode likewise. Or we can further in place here. So we can see like here we can have the connection, or we can put in between any of the two vertical lines. Okay, we can put anywhere, or we can put here also. Okay, so we can put in 19 and 20 terminals. So 20 will be indicating the vertical 20 vertical line, or the column line will be basically indicating the anode pins, and the 19 will be indicating the cathode. Okay, so this is one thing. Also, we need to use the register. So we'll take the register. We can't connect registers likewise because both the terminals of the register will be having same voltage. So we can't connect likewise. So we will be rotating it. Once we will be rotating it, we will be placing to two different, its two terminals will be placed to two vertical lines. Okay. Place here also, but likewise. And we need to have a switch. So we'll be taking a switch. And again, because we can't put the switch, all the terminals of the switch into the same vertical line because all will be sorted. So it will not be working. So we should be rotating it such that it should be connected with three different lines. Okay. So whenever you have by mistake you have connected likewise, you can put the escape. It will be disconnected. Okay. Or if you want to remove anything, like suppose we have selected this button, but we want to remove it. We don't want it. We want to use the wires. So we should be pressing escape into the button keyboard. It will be deleted basically. Now we need to do the connections. So here, so this is the negative terminal. So suppose this negative we want to connect with this terminal. So we should be connecting here, taking it here and connecting it. Once we connect it here, it will be connecting through all these vertical lines. Okay, so now this ground is connected, or negative terminal is connected with this wire. So negative terminal coming out here. This negative terminal should be connected with cathode. So we should be making this connection. So this line now, because this is vertically short up to here. So either we can connect this pin or this pin, both is same thing, and connected to this one. So it will be connected to cathode. So this is the anode part. Anode part we should be connecting with one of the terminal of the switch, and we should be making it to red color because it is positive now. Because this is the cathode negative one, this is the positive, so we will be changing the color of the wires. So now this is the common one. So common one should be connected to the positive one. So this is the down line. Down horizontal line is basically going to have the positive terminal. So we will be clicking it here. Now the connection is done. Okay. So we'll be using this breadboard to utilize the basics of like connection, because we will be having two different wires into the lab. So once you want to connect the wires, you need to just place these wire terminals into these holes. It will be by default connected. You need to uh, rotate these wires directly putting into holes, and these holes will be automatically connected. Like a resistance will be there. Resistance will be at two different terminals. Two different terminals. By bending it, we will be placing into two different holes here and here. So it will get connected basically. So likewise, we will be utilizing the breadboard to make the connection. So this is the basic connection. Once we have done the connection, we will be doing the start simulation. So once we do the start simulation, you can just see it is glowing because it is on. If we place it, turn it off, it will be off now. On and off. If you want to change the value of resistance, you can come here. 1 kilo ohm is there. You want to make it to ohms. So suppose you have made it ohms. We need to stop it and then again start it. Then you can just see here again the current is showing. Like it is very high. So we need to stop it again and change its value. We are not getting the option to rotate basically. Have like 1 kilo ohm, and then we will be placing it here. In the resistance case, we can in resistance the terminals are not like positive and negative. Any terminal can be positive and any terminal can be negative. So there is no positive and negative. So we can connect in any direction, either this way or we can connect either this way also. So we'll be starting and we'll be turning it on and off. Likewise, we can utilize the breadboard connect power circuit. Okay, so this is the basics of making the connections. Now we will see some basics about the Arduino. Okay, so we will have the next circuit that is related to the Arduino. So we will be using Arduino Uno basically. That is available into our lab also. This is the Arduino Uno kit that we will be using. So we will just go with the introduction to this Arduino Uno kit. So here, I hope it is visible to everyone. Okay. So here into this Arduino Uno, this is basically the microcontroller that basically does the each decision making based on the input provided to it. Okay. So here this will be a reset pin. Once whatever the programs we have burned in here or the programs we have written inside this microcontroller, we can reset it and it will be resetted. But means whatever the programs it has been programmed previously, it will be deleted now. Okay. So this is where we should be providing the power supply separately, or we can use the USB pins directly to provide the power pins. Okay. So in that case, here there are different input and output pins. So here you can see this is written like digital. That means these pins starting with 0 to 13. Okay, these are considered the digital pins. So digital pins means pins that will be providing either 0 or 1 as the output, or it will be taking either 0 or 1 as the input. Okay, so that's why it is called the digital pins. So if you want to use any sensor or any input and output that is related to digital input and output conditions, we will be utilizing these terminals. So where it is written digital. So starting with 0 to 13. Okay. Similarly, in this case, analog inputs are the content. So here A0, A1, A2, A3, A4, A5, they are considered the analog inputs and outputs. So if you want to provide analog inputs to the microcontroller, we can provide through this. If you want to take analog outputs from here, you can take this. So each terminals, each pins starting with like digital D0 to like D13, it will be like the digital pins. Similarly, A0 to A15, A5, it will be like 6 pins are there for analog conditioning. Analog in the sense like if you want to provide 0.2 value. Okay, so 0.2 will be read by these terminals. Or if the 0.2 is the output, then we can take the 0.2 as the output from these analog pins. Okay, this is the difference between analog and digital. In case of digital pins, it will be providing only 0 or 1 as the output, or it will be only taking 0 and 1 as the input. Next one is the power. So in the power here, starting with like a reset again, once we will be providing here the values, it will be resetting the output device, whatever, like it will be making it 0. 3.3 is the if any uh, if we connect it to this terminal, it will be providing 3.3 volt. Similarly, this will be providing 5 volt. This is ground. This is another ground. This is V input. If you want to put the input here to the microcontroller, we can provide the input from here. Input out reference. This is for input out reference. Basically, this is basically the reserved or unused. Basically, it can be used for further processing. So it is unused. Okay, so this is the basics about the Arduino Uno. Now we will do some connections. Like we can program this Arduino Uno for basic uh, LED blinking. So consider an LED blinking is there. So like the LED blinking that we have implemented with the help of battery and with the help of a switch. Suppose instead of a switch, we want to uh, program this Arduino so that it should be blinking the LED after certain interval. So we will be programming this Arduino so that instead of a switch, we can use this directly. So to make the connections, we need breadboard. So we will be searching for breadboard. So this will be our breadboard. Now we want to have LEDs. So we'll be taking LEDs. Okay. So we'll be making the connections to LEDs likewise. We want a register. If we want to use LEDs, we need to have a register. We can directly connect likewise also. If we connect likewise, there will be no use of wire. It will be directly get connected. Okay. Okay. So now because this is the case, we need to utilize the positive terminal and the negative terminal. So how we should be basically connecting. So suppose this is the terminal we want to connect with suppose pin number 5. D5 we are connecting. Okay. And this is the cathode. So what we can do is we can rotate it. So now this side anode is there. So this is positive. That means if this D5 is positive, okay, and then at that time this is ground, we will be making this connected to the ground. So we can use ground as this pin. Okay. So if this is our positive terminal, so we will be making it red. This is ground. So we will be making it the black color. So this is the ground. So we need to connect this ground. This this pin. Okay. So now this is the ground connected. This is connected to cathode. Anode is connected with the resistor, and this is connected to the terminal 5 of the Arduino. Okay. So now the LED will be glowing once the positive terminal or anode is connected with the positive voltage and the cathode is connected with the negative terminal or ground. So ground we have connected. If in the microcontroller, if we program it so that after certain interval it makes this D5 pin to 1, then this LED will be glowing. If it make it to 0, the LED will be off. So it's programming we will be doing with the help of the code. Okay. So once we click it here, so inside this system, whatever the connections we are making, they basically make a block diagram of it. Okay. This is the block diagram. So we will not be using the block diagram. We will be using the code basically. Okay. So we will be clicking on the code in the text format. So this is the basic code of the LEDs. This circuit that we have made. Okay. So we will just so this is the basic circuit. Okay. So whenever we will be going with the programming in case of Arduino, the first step. So this is basically C++ programming is there here, or basic C is there. So for comments, we will be using slash, okay, double slash basically. So initial steps of programming will be once we go for writing the program, it will be having two different sections. So wide setup and wide loop. So wide setup is inside this wide setup, whatever the commands we will be providing, that will be executed for one time. But in void loop, whatever the commands we are providing, that will be repeating, okay, again and again. It will be repeating in a loop. That's why it is called like wide loop. Wide loop is there. So inside that, whatever we will like writing, it will be like a loop. It will be rotating like a loop basically. Before that, there is another step that is initialize basically. So we'll be making initialize. So initialization of what? Initialization of different pins that we are using into the Arduino Uno board. So here we are using D5 pins. Okay. So here, if we are using D5 pins, then we will be initializing it like an integer. So we'll be initializing it as an integer with a variable. So because we are using it as an LED pins, so we'll be making it as a variable name like LED. So we'll be making it as a LED pin. Okay. So we are having LED. So we'll be using it LED as a variable name. So this is the variable name. And this variable name LED is connected with D5 terminal. So we will be making it like 5. Then we will be stopping this by semicolon basically. Okay. So this is how the initialization will be done. Suppose we are using two different pins here, D1, D2, likewise. So all these pins we will be requiring to initialize here. Suppose we are also utilizing, but we are suppose having two different LEDs are there. So we will be utilizing this initialization section with integer LED1 and LED2 with LED1 with 5, LED2 with suppose 6 is there. So we'll be utilizing like LED2 is equals to 6. So here pin number 5 is initialized to an variable that is LED. Okay, this is the basic idea. So whatever the pins we will be utilizing, we will be initializing it, except the power terminals. If we are using the analog terminals, we need to initialize that also into before this void setup. Also, if we are utilizing the digital pins, we need to initialize it. So we are utilizing only one pin. So we are initializing only one variable like LED. This variable can be anything. PAR we can write. Okay, any value we can write to initialize. So it is just like an variable. In this LED variable, we are storing the value of the D5 pin basically. Okay, so once we have done the initialization, now we will be going to the void setup. So here, in case of the void setup, basically we make sure like this pin, that is it you initialize by a variable name, in what particular mode it is working. Okay, so in what particular mode it is working, we should be initializing it. So if it is working in as an output mode, or if it is working as an input mode, we should be initializing it. So pin mode is the basic command we should be providing. This is the variable name. Okay, the variable name that we have assigned is here LED. So we will be putting only the LED. So this is the variable name, and then comma, with the comma, we will be providing like either it is working as an input pin or output pin. Because we are taking positive terminal from here, so this is an output pin to this LED. Okay, so this is an output pin to this LED. That's why we are making it to output pin. If suppose other pins we have utilized like D6, that is also we have utilized. So we will be again initial setting it this pin mode, this LED1, this LED2 to output pin. So we'll be making the other pin also to output pin, either it is output or input based on that. Whatever pins we will be utilizing, we will be making its initialization, and then we will be setting its mode like either it is working in input mode or output mode. So we can just write like setup output or input of pin. That is basically used for wide setup. Okay. So next one is wide loop. So in the wide loop, it is like a and also right here. Executed for only one time. This loop is there. This is executed for executed as a loop for infinite iterations are like executed as a loop. Okay, it will be continuously executing. Continuously executing. Okay, so this is all the sections that we will be putting inside this will be continuously executing. So this is one thing, and here in the loop, how it should be working. So we will be providing this D5 terminal with some high voltage like 1, and then after some time we will be providing it the 0. So 1 and 0 we will be keep on making. So once we will be making it 0 and 1, it will be keep on activating this like the LED 1 0 1 0, likewise it will be showing. So how we will be providing it. So there are how we should be writing, that is basically decided by the command like digital write, because we are utilizing digital pins. Okay, so we'll be writing it here digital write. So digital write is the code, and this the first is the variable name. So variable name we have provided LED. So we'll be writing LED. So initially it is 0, so we'll be making it like high. So high is there, then stopping the command, then providing some delay. So there is a delay command. So delay with 1000. So this 1000 is in micro, or this 1000 is basically for milliseconds. Okay, so if you are providing 1000, it means 1000 millisecond it is talking about. So it will be making a delay of 1000 millisecond. Similarly, after making a delay of 1000 millisecond, we will be again writing this pin. So digital write this pin, that is name is assigned to a variable LED to low. Initially it has been high, then it will be made to low after 100 milliseconds. Again after that we will be making a delay of 1000 millisecond, and after that it will keep on rotating because it is a loop. So after completing this, again it will be writing the LED to high, then again delay, then again to low, then delay, then writing high, delay, low, delay, high, and keep on doing until we stop this. Okay, so this is the basics of the programming for turning the LED on and off. So once we have done it, okay, so once we have done it, we will be making this start simulation. So once we do the start simulation, okay, so it is saying like how to debug, how the debugger works. So add breakpoints by clicking on the line numbers, hover over the variables while paused to see their values, use the button above to resume simulation, or step one line at a time. So based on like how we can debug it, if there is some error, we can make the debuggings also. Okay, uh, by stopping and turning it on and off. Okay, so if there is some error is there, we will be debugging it also. Where there is an error, it will be highlighting. So we can go there and we can modify and then start the execution. So you can just see LED is turning on, then off, on and off likewise. So it is based on the delay. Okay, so it is once this Arduino is on, there will be a light glowing on this Arduino also. There is an on light, green light is there, this one. Similarly on the lab also, we will be having this Arduino with LEDs. If it is glowing, that means it is on. This is the basics of Arduino programming. We can change it. Uh, suppose we can stop it. Suppose we have done like we have initialized it 1. Sorry. This variable we have named it like 1, LED 1, and then by mistake we have done it here. We have written LED variable, but here we have defined it as LED 1. So if we start executing, just see like how the errors are indicated. So once we start it, okay, so it will tell you like there is an error. So sorry, it seems like your code has some errors. So it will be letting you know like there is an error. So where this error is there, so whenever you are using this LED, it is basically providing you. Okay. So LED was not declared in this scope. So we are utilizing this LED variable, but initially it is not initialized. We have initialized it as LED 1. So we need to initialize it as an LED 1 only everywhere. Then only it will be perfect. 1, then LED 1, then LED 1, and then we can start. So once it is done, it will be executed. Okay, 0 and 1 likewise. So this is the basics of the LED programming in case of Arduino. Okay, so this is based on like we are not providing any input to the this Arduino, but we are programming it so that it is providing input to this LED without any input provided to Arduino. We can provide some input, that means like an if and else command. If we are providing a sensor data, if the sensor data is high, then it should be providing high to this pin. Otherwise, it should be making it low. So there is like if and else type of command. Okay, so we can use if and else type of command to use the sensor data. So that part we will see into the next class. Okay, so we will just have like we can how we can use, we can click on this, we can skip the code part. We want to suppose use two different LEDs. Okay, so if we want to use two different LEDs, and then we will just flipping it. This is the positive terminal. Okay, so again we will be utilizing a resistor, and then we will be rotating it positive terminal. Okay, we want to use suppose D10. Okay, and we want to make it color like yellow, or some other color green. Okay, and this should be connected to the ground. If we make it to ground, and it should be ground, so it is black. So once we have crossed two different terminals, but it is not connected, because you can just see if we highlight it, there is no highlight of this black color. If we cross two wires, there will be no connections. If you want to make connection from here, we need to drop here, and then we need to start and drop here, then it will be a connection here. If we are crossing a wire, there is no connection between a crossing of a wire. Okay. So now we have made the connections, two LEDs are there. So now we need to program it also. In the program, we will be making sure like the LED should be, so if there is two LEDs or like one LED is there, so it is like 0 and 1. Once it is 0 and 1, 0 and 1, likewise it is creating. If two LEDs are there, we want to create it like this is 0, 0, 0, 1, 1, 0, 1, 1. So four possible combinations are there with like two LEDs, both can glow, one can glow, otherwise off. Likewise, both are on, and another one is on, another one is off. Likewise, we can create like 0, 0, 0, 1, 1, 0, 1, 1. So to create that, we want to have a programming. So we want to use this again. Okay. So because we are having two different LEDs, so again we need to use this command for two different times. Okay. So one will be LED 1, another will be LED 2. So LED 2 we are connected with the terminal 10. So we will be writing terminal 10. Okay. Next is our void setup. In the void setup, we need to again provide like this pin is working in what particular mode. So LED 1 is already working in 1, LED 2 that is equivalent to pin number 10 is working in on output mode. Means these two pins are providing output to the LEDs. Okay. Next is in case of writing. Now in case of writing, we will be writing like, so initially both the LEDs should be like 0. So 0 means we should be making it low. After that, some delay will be there, and after the delay, we should be utilizing this like this is LED 1. So LED 1 should be high, and LED 2 should be low. Okay. Next one is this one should be low, and this should be high. Again, we'll be copying and pasting. Both should be high. Okay. So this is like this is going to create 0, 0, 0, 1, 1, 0, 1, 1 type of system. Okay. So we'll be starting the execution, and we'll see. You can just see, note it down, both are 1, then both are 0, then this one, then again both 1, 0, this is 1, this is 1, 0, 2, 3, then 0, likewise. So we can program it. Okay. So this is all about the basics of a circuit diagram, like how we can do the circuiting and how we can program the Arduino also for basic LED blinking. How we need to make the connections. This is how we should be making the connections. Okay. So I hope you have got the point about the basics of Tinkercad.